Alright everyone, so this is Selin. Selin is one of the most fast learning students in J8. So she actually wasn't here for 3 weeks of the program. So 2 weeks in, she just left and went to Turkey, which was really jarring for me because her project was in like a half-finished state and we had to rush it in. But yeah, so working with Selin was really great because this ball tracking robot, a common flaw with this model is that one motor is always faster than the other, and it's just a common problem. And so we spent a lot of time working to try and get the speeds of the motors to run at the same speed. And I remember there was a point where I was looking at it and I was like, okay, Selin, we spent like a whole day on this. This is pretty good. This is pretty good. So there's two options I can give you. We can stay with this, or we can do a bunch of math, we can do a bunch of programming, and I can teach you some honestly like entry college level topics to get the angle like completely precise. And she was like, yeah, let's do it. And so we spent a lot of time just debugging the math, the code, just making sure everything worked, and I'm really happy to showcase you Selin and her human following robot.
Hi everyone, I'm Selin and I go to Castaway School. My project is the human following robot, and I chose it because I'm really into robotics. I do FRC, and I just want to get a good idea of all of the components of a robot. So a quick overview of how it works. The main components are the ultrasonic distance sensor over here and the obstacle detection modules on these two sides, which help the robot follow my hand. I'll show you guys a quick demo. The ultrasonic distance module over here sends ultrasonic sound waves, and these are sound waves which are higher pitched than what the human ear can hear. So when I put my hand in front of it, these sound waves bounce off and go back into the module, and with that I can then calculate how far the module is from my hand, and then I programmed it, so I programmed the Arduino over here, this is like the brain of the robot, and I set it so that even if I move my hand backwards, the module will seek out to maintain that distance between my hand and the module, and that will cause the robot to move forward and follow my hand. As for the obstacle detection modules on the each side, these modules sense infrared light, and when they're obstructed by my hand, there's a light that goes off over here. It's not on right now, but there's a light that goes off indicating that they're obstructed, and when that happens, I programmed it so that they turn. So if the right module is obstructed, they'll turn right, and so on and so forth. As for my modification, I implemented an IR remote, and it has a receiver over here, so I can demonstrate how that works. So if I press number 2, it'll move forward. If I press 8, it'll move backward. If I press 3, it'll do a turn. If I press 1, it'll do another turn. And yeah. And how this works is that when I press a number on the IR remote, it'll send a signal to the receiver over here, and then the receiver can then decode which of these buttons send that message, send that signal, and then it'll run the code for each of the buttons. My final modification was getting this robot to drive straight, as Niraj mentioned. This was also my biggest challenge throughout this entire process. So when I first started experimenting with this robot, I noticed that the wheels would spin at different speeds because of a natural variation that's pretty common. And in order to compensate for that, I installed an accelerometer over here. And by using its gyroscope function, I was able to figure out the angular velocity of the robot. And by integrating the angular velocity over time, I was then able to get the true angle of the robot rather than where it thinks it's going. In my code, I then monitor that that true angle, and if it ever goes over 1 degree, then the robot's motor speeds adjust themselves automatically in order to compensate for that change in speed. This is actually quite similar to a PID controller, which is used in more large-scale robots, but this is kind of a smaller-scale robot, so it's just the P of the PID controller. Throughout this entire process, I've learned so much about coding and C++ specifically. I've also gotten a way better understanding of different kinds of sensors I can use within a robot. I've also learned a lot of moral lessons about patience, persistence, and about being resourceful. For my next steps, I hope to apply my knowledge to FRC and larger scale robots. I also want to experiment with different kinds of sensors. Thank you. Any questions?
What is a PID controller?
I love this question. So, a PID controller, PID stands for Proportional Integral Derivative Controller. And the proportional basically means that the amount of correction is proportional to the amount of error caused by the robot. The I integral means that you take into account the accumulated error over time, and that helps eliminate the gap between what the robot's doing and what you want it to actually be doing. The D derivative means that you're taking into account the rate of change of error, and this basically ensures a more consistent and stable robot. Any others?
It seems like you have chosen to really perfect the core functionality of the robot versus trying to add a bunch of new features. What drove that decision?
I think that I'm a person who doesn't like to do things halfway. I like to fully finish one thing before I move on to the other. So I think perfecting the core properties of this robot was really important to me. Yeah, thank you. Oh, Priya.
I was gonna ask, so it's super cool that instead of figuring out the specific offset of your motors, you're kind of creating something which is constantly correcting itself. How often does it correct itself within the code?
How often? I believe it's not a matter of time. It's whenever it goes over 1 degree, it just corrects itself. And yeah, that's basically it.
Is there any reason you use 3 wheels instead of 4 wheels?
What?
Is there any reason you use 3 wheels instead of 4 wheels for a normal car?
I don't know. I just felt like it.